Good day, class. I am Ma'am April May G. Agustin, and for today, we will be discussing another lesson which is all about geothermal energy and hydropower resources. Before we proceed in discussing our lesson for today, let us first have our opening prayer. Let us bow our heads and feel the presence of our Lord. God of grace, we open our hearts, minds, and souls to worship to you. Thank you that today we dwell in your kingdom and live in your presence. Thank you that as we gather together, we join with all Christians across the world to glorify your holy name. Come be with us, inspire us, and lead us in our time together. We ask all this in the beautiful name of Jesus. Amen. For your attendance, just like the same with the pre-recorded video lesson that we have, kindly listen attentively and participate with the online virtual activities. You can use the comment section below in typing down your answers. And for every activity, please don't forget to include your complete name and section that will serve as your attendance for today. Okay, so let us now proceed in discussing our lesson. Today's lesson objectives are the following. Number 1, to determine what is geothermal energy. Number 2, to explain how heat from inside the earth and from flowing water is tapped as a source of energy for human use. Number 3, to explain the stages on harnessing geothermal and hydroelectric energy for human consumption. And last one, to value the importance of these resources by means of identifying the advantages and disadvantages of using it. Let us first have a recall of our previous lesson. Last time, we have discussed the formation of fossil fuel, the advantage and disadvantages of fossil fuels, and the future of fossil fuel. For our review, kindly determine the images below. All the images are related with fossil fuel. After determining the image, kindly provide a short description for each. You will be notified with a heart and a thumbs up if you got the correct answer. Kindly type your answers in the comment section below. So I am giving you 2 minutes to answer this activity. You may start now. Okay, so let us now check your answers. So the first image is a picture of a coal. So what is a coal? A coal is a combustible black or brownish black sedimentary rock. How about the second image? It is an image of a generating station. And what is the main function of a generating station? It is a facility for the generation of electric power. Now let's move on with the last image. It is an image of a pump jack. And what is the function of a pump jack? A pump jack is the overground drive for a reciprocating piston pump in an oil well. Did you get the correct answer? Okay, so let us now proceed. The interior of the earth is hot, as volcanoes, geysers, and hot spring shows. Beneath our feet lies a huge energy potential. In deep geothermal energy, the heat energy stored in the upper kilometers of the Earth's crust is used. In the interior of the Earth, temperatures are around 5,000 to 6,000 degrees Celsius. Now let us proceed in discussing geothermal energy and hydropower resources. Why is Earth hot inside? The heat of the Earth's interior comes from a variety of sources. These include the heat contained in the objects that accreted to form Earth, and the heat produced when they collided. As the Earth grew larger, the increased pressure on Earth's interior caused it to compress and heat up. Heat also came from friction when melted materials was redistributed within the Earth, forming the core and mantle. Now let's discuss what is geothermal energy. Geothermal energy comes from the heat within the Earth. The word geothermal comes from the Greek words geo, meaning earth, and therme, meaning heat. People around the world use geothermal energy to produce electricity, to heat buildings and greenhouses, and for other purposes. Geothermal energy as renewable energy source. Geothermal energy is a renewable energy source because heat is continuously produced inside the earth. Geothermal energy is called a renewable energy source because the water is replenished by rainfall and the heat is continuously produced by the earth. Geothermal energy is a renewable resource because the earth has been emitting heat for about 4.5 billion years and will continue to emit heat for billions of years into the future because of the ongoing radioactive decay in the Earth's core. How geothermal energy is captured. People can capture geothermal energy through the following. The first one is by means of using geothermal power plants. Geothermal power plants uses heat from deep inside the earth to generate steam to make electricity. The second one is geothermal heat pumps. Geothermal heat pumps, which tap into heat close to the earth's surface to heat water or provide heat for buildings. How does a geothermal power plant works? Hot water is pumped from deep underground through a well under high pressure. When the water reaches the surface, the pressure is dropped, which causes the water to turn into steam. The steam spins a turbine, which is connected to a generator to produce electricity. The steam cools off in a cooling tower and condenses back to water. The cooled water is pumped back into the earth to begin the process again. For us to better understand how geothermal power plant works, let us now proceed in watching a short video clip about geothermal power plants.
You may have relaxed in a natural hot springs pool, or seen the old faithful geyser blasting hot water into the air in Yellowstone National Park. But have you ever thought of where all that heat comes from? Well, it comes from deep beneath the surface of the Earth, and it's called geothermal energy. And we can use it to generate clean, renewable electricity. Okay, here's how geothermal works. Heat from the Earth's crust warms water that has seeped into underground reservoirs. In some places, when water becomes hot enough, it can break through the Earth's surface as steam or hot water. This usually happens where the Earth's crust, or plates, meet and shift. In the past, taking advantage of geothermal energy was limited to areas where hot water flowed near the surface. But as geothermal technologies advance, we can leverage even more of these natural, renewable energy sources. Engineers have developed a few different ways to produce power from geothermal wells drilled into the ground. Have a look at this. It's a dry steam geothermal power plant, and it's the most common type of geothermal technology used today. Underground steam flows directly to a turbine to drive a generator that produces electricity. Pretty straightforward. Another geothermal technology is called a flash steam power plant. A pump pushes hot fluid into a tank at the surface, where it cools. As it cools, the fluid flashes, or quickly turns into vapor. The vapor then drives a turbine and powers a generator. A binary cycle plant works differently. It uses two types of fluid. Hot fluid from underground heats a second fluid, called a heat transfer fluid, in a giant heat exchanger. The second fluid has a much lower boiling point than the first fluid, and so it flashes into vapor at a lower temperature. When the second fluid flashes, it spins a turbine that drives a generator. The environmental benefits of this clean, round-the-clock, renewable energy source are substantial. Low emissions, small physical footprint, and minimal environmental impact. The few byproducts that can come up are often re-injected underground. Geothermal energy can also help recycle wastewater. In California, wastewater from the city of Santa Rosa is injected into the ground to generate more geothermal energy. Some plants do produce solid waste, but that solid waste may contain minerals that we can remove and sell, which lowers the cost of this energy source. The U.S. Geological Survey estimates that untapped geothermal resources in the United States, if developed, could supply the equivalent of 10% of today's energy needs and cut our dependence on fossil fuels. In fact, electricity generated by geothermal energy already provides about 60% of the power along the Northern California coast, from the Golden Gate Bridge to the Oregon state line. Geothermal energy, helping to push America toward energy independence and a clean, renewable way to meet our growing energy demands.
Let us now proceed in discussing geothermal heat pumps and how does it works. Water or a refrigerant moves through a loop of pipes. When the weather is cold, the water or refrigerant heats up as it travels through the part of the loop that's buried underground. Once it gets back above the ground, the warm water or refrigerant transfer heat into the building. The water or refrigerant cools down after its heat is transferred. It is pumped back underground where it heats up once more, starting the process again. On a hot day, the system can run in reverse. The water or refrigerant cools the building and then is pumped underground where extra heat is transferred to the ground around the pipes. For us to better understand how geothermal heat pumps work, let us now proceed in watching a short video clip about geothermal heat pumps.
We all want to save money heating and cooling our house or office, right? The answer may be under your feet, literally. Much of the heating and cooling can come from the ground, below the surface, with something called a geothermal heat pump. You see, below the frost line, about 10 feet down, the Earth maintains a nearly constant temperature of 54 degrees. We can tap into this energy to provide heating in the winter and cooling in the summer. Okay, now here's how it works. Bury a loop of pipes, called a heat exchanger, just below the surface, and fill them with water or a water and antifreeze solution. During the winter months, the air is usually cooler than the temperature below ground. The solution circulates in a loop underground and absorbs the Earth's heat. This heat is brought to the surface and transferred to a heat pump. The heat pump warms the air, and then your regular heating system warms the air some more to a comfortable temperature. Finally, ducts circulate the air to the various rooms. Now, a huge benefit is that the geothermal system doesn't have to work as hard to make people inside comfortably warm, and you save lots of money on your heating bill. In the summertime, the system works in reverse. When it's hot outside, the temperature below the surface is cooler than the summer heat. So, the fluid in the loop absorbs heat in the building and sends it underground. The ground's lower temperature cools it, and it's circulated again and again. Now you're saving money on air conditioning. Now, this church uses a large geothermal heat pump to heat and cool the building. It has a very big parking lot, which lets it spread out its loop horizontally. But if you don't have all that space, you can go straight down and use a vertical loop system instead. Geothermal heat pumps can be used just about anywhere in the US because all areas have nearly constant shallow ground temperatures, although systems in different locations will have varying degrees of efficiency and cost savings. The constant temperature of the Earth just below our feet is a sustainable resource, literally in our own backyard. It's a clean energy source ready for us to use, to heat and cool our homes and buildings while lowering our utility bills.
Did you know that people have used geothermal energy for thousands of years? Ancient Romans, Chinese, and Native American cultures used hot mineral springs for bathing, cooking, and eating. Most people in Iceland also use geothermal energy to heat water and buildings. And many of the best locations for geothermal energy are found in the Ring of Fire, a horseshoe-shaped area around the Pacific Ocean that experiences a lot of earthquakes and volcanic eruptions. That's because hot magma is very close to the Earth's surface there. Let's localize. So this is a list of the different geothermal power plants that are situated in the Philippines. You can have a screenshot of this portion. Now let's move on in discussing what is a hydropower. Hydropower or hydroelectric power is one of the oldest and largest sources of renewable energy. which uses the natural flow of moving water to generate electricity. Some may be very large, but they can be tiny too, taking advantage of water flows in municipal water facilities or irrigation ditches. The hydropower resource. On Earth, water is constantly moved around in various states. A process known as the hydrologic cycle, or also known as the water cycle. Water evaporates from the oceans, forming into clouds, falling out as rain and snow, gathering into streams and rivers, and flowing back to the sea. All this movement provides an enormous opportunity to harness useful energy. In order to generate electricity from the kinetic energy in moving water, the water has to move with sufficient speed and volume to spin a propeller-like device called a turbine, which in turn rotates a generator to generate electricity. Roughly speaking, 1 gallon of water per second falling 100 feet can generate 1 kilowatt of electricity. For us to better understand the hydropower resource, let us now watch a short video clip.
Hydropower. Hydropower, or hydroelectricity, refers to the conversion of energy from flowing water into electricity. It is considered a renewable energy source because the water cycle is constantly renewed by the sun. One of the first uses of hydro energy was for mechanical milling, such as grinding grains. But today, modern hydro plants produce electricity using turbines and generators. The mechanical energy created by moving water spins rotors on a turbine. This turbine is connected to an electromagnetic generator, which produces electricity when the turbine spins. There are two main types of hydroelectricity production: dams and run-of-river. Hydro dams utilize the potential energy from dammed water to produce electricity. A dam is a large barrier constructed to raise the level of water and control its flow. The elevation created by the dam creates gravitational force for turning the turbine when water is released. Some dams also contain an additional reservoir at their base where water is stored to be pumped to the higher reservoir for release when electricity is in demand. This is referred to as pumped storage hydro. The second form of hydroelectricity production is run-of-river hydro. Run-of-river still uses turbines and generators, but relies on natural water flow rates of rivers, diverting just a portion of the water through turbines. Because run-of-river hydro is subject to natural water variability, it is more intermittent than dammed hydro. There are various sizes of hydro plants that produce electricity. Large hydro, greater than 30 megawatts, small hydro, 100 kilowatts to 30 megawatts, and micro hydro, less than 100 kilowatts. The Hoover Dam in the United States is a whopping 2,074 megawatts, which is enough to serve 1.3 million people. Of all renewable energy sources, hydropower holds the largest share of worldwide electricity production. Hydropower has several benefits. It is a cost-competitive form of electricity, even though the initial building cost can be high. It is quite reliable compared to other renewable options and pairs well with other sources as it can be used as baseload power. In some cases, dammed reservoirs can also help with flood control and be a reliable water supply for communities. There are also some concerns with hydropower, especially when it comes to large dams. Damming a river has a major impact on the local environment, changing wildlife habitats, blocking fish passage, and often forcing people in riverside communities to move out of their homes. In addition, dam failures can be catastrophic, claiming the lives of those living downstream. Hydro plants are also not completely free of greenhouse gas emissions. As with most forms of energy, carbon dioxide emissions happen during construction, particularly due to the large quantities of cement used, and plant matter in the flooded areas makes methane, another greenhouse gas, as it decays underwater. That's hydropower.
Let's localize. So this is a list of the different hydroelectric power plants that is situated in the Philippines. You can have a screenshot of this portion for your reference. Now let's move on in discussing the advantages and disadvantages of geothermal and hydroelectric power plants. What are the advantages of using geothermal power plants? This energy source is more environmental friendly than conventional fuel sources, a source of renewable energy, and the number of exploitable geothermal resources will increase with ongoing research and development in the industry. It is also a sustainable source of energy as it's always available, unlike wind and solar. It is also a reliable source as it's easier to predict the power output from a geothermal plant with a high degree of accuracy. No fuel is required, and pollution levels are much lower compared to fossil fuels. What are the disadvantages of using geothermal power plants? The largest single disadvantage of geothermal energy is that it is location specific. Gases are released into the atmosphere during digging. Geothermal energy runs the risk of triggering earthquakes, expensive resource to tap into, with high upfront cost ranging from around $2 to $7 million for a plant with a 1 megawatt capacity. Energy fluid needs to be pumped back into the underground reservoir faster than it is depleted. Management is required to maintain sustainability. Let us now proceed in discussing the advantages and disadvantages of using hydroelectric power plants. So the advantages of using a hydroelectric power plants are the following. It is renewable, or the source is renewable, low emission, reliable, and safe. And for the disadvantages, it includes environmental consequences, expensive to build, drought potential, and with limited reserves. Okay, so we are now done discussing your lesson for today. Let us now move on with your first activity. So what you're going to do is to briefly answer the following questions. You can use the comment section below to type in your answer. So I am giving you 2 minutes to do this activity. We're going to check it later. You may start now. Okay, time's up. So let us now check your activity. So the first question is, what is geothermal energy? So when we say geothermal energy is the heat that comes from the subsurface of the earth. Second question, what is hydroelectric energy? Hydroelectric energy is a form of energy that harnesses the power of water in motion, such as water flowing over a waterfall to generate electricity. Third question, what type of resource does geothermal and hydroelectric belongs? So geothermal and hydroelectric are renewable sources of energies and produce clean fuel sources. Did you get the correct answer? Okay, very good. Now let's move on. Let us now proceed in discussing the practical applications of geothermal and hydroelectric energy in our life. Direct use of geothermal resources is the use of underground hot water to heat buildings, grow plants in greenhouses, dehydrate onions and garlic, heat water for fish farming, pasteurize milk, and for many other applications. Some cities pipe the hot water under roads and sidewalks to melt snow. A primary use of hydropower energy is to produce electricity. The main ingredients of hydroelectric power plants are dams, rivers, and turbines. Plants use dams to create reservoirs where the water is stored. This water is then released through turbines and spun to activate generators and create electricity. Points to remember. Geothermal energy comes from the heat in the Earth's core. This heat creates underground reservoirs of steam and hot water, which can be tapped to generate electricity or to heat and cool buildings directly. Geothermal energy is the third largest source of renewable energy behind hydropower and biomass. On the other hand, hydropower is one of the oldest power sources on the planet, generating power when flowing water spins a wheel or turbine. It was used by farmers as far back as ancient Greece for mechanical tasks like grinding grain. Hydropower is also a renewable energy source and produces no air pollution or toxic byproducts. For the evaluation, kindly check the description of the video and click the provided link. Thank you so much for attending my class today, and I hope that you have learned something. All the pictures and informations used in the PowerPoint presentation are credits to the rightful owner.